values in the matrix, and I'm just going to do it with you. All right, so that is the graph, and then you draw your matrix. So obviously, I'm sure you guys would have seen that you list all the vertices from A to J in this case, without or without I, along the top and then along the side. All right, so that's what your table must look like. It's fine if you don't have the lines yet, you can just do like the letters and then just fill them in afterwards. Yeah, sometimes they say you only have to fill in the upper triangular matrix or the lower triangular matrix, but if they don't say anything, you'll fill it in on both sides. Yeah. Yes.
That in like it's a simple undirected graph, but that's what we do. It was like from B to D is 4, but D to B is like double that. Would you have to fill it in differently?
Yeah, but remember those ones are actually not in the syllabus anymore. So yeah, I think we said that like right at the beginning of grade 10, that directed graphs actually aren't tested. But yes, you would then have a different top half and bottom half. It would be different then, yeah. And now? It's fine. Okay, guys, can we start filling it in? All right, you can do the lines later. So now what you're going to put in these blocks of your table, of your adjacency matrix, is actually the weights of the edges. All right, so they say in the book that it is easier if you do them in alphabetical order. Doesn't really matter. So what you can also do is you can tick off an edge once you fold it in twice. All right, so AB, for example, we're going to fill it in underneath A and next to B, so that weight is 8. But then there's another AB in this matrix over there. So we must fill that 8 in over there as well. All right, now I'm done with AB. Now I'm going to tick it off. So you can do it like that. You don't have to do it in alphabetical order, okay? Just as long as you fill in all of them. Then let's do AC is 10. So AC is 10. But then there's another AC over there, which is also 10. And then we tick it off. Right, AJ is 12. So I'm going to go to the bottom. AJ, I'm going to fill in as 12. And then over there, AJ is 12 again. And now I'm going to tick it off. Now, guys, do we notice that the degree of A is 3? Do you remember what degree means when we're talking about graphs? The number of edges attached to a vertex is 3. Now we have to have 3 entries in our table across from A. So underneath A, we have 3 entries, and across from A, we have 3 entries. Okay, that's a nice way of checking that you have actually filled in all of the edges connected to A. So the degree of A here is 3. Remember, we used that, I think, when we did Dijkstra's algorithm last year. It was the last time we really spoke about degree. And the Chinese postman problem as well. All right, now you can decide, do you want to now do B because that's alphabetical, or do you want to move along the graph just as you want? Okay, it doesn't really matter. I'll do from B. So BC is 6. So now you look for BC 6, and that BC also 6, and then you tick it off. All right, BD is 4, so BD and BD. Okay, the degree of B is 3, and we have 3 entries under B and 3 entries across from B. Okay, so we're done with B basically. You can even tick off the vertices as you finish them as well, if that will help. So we finished A and now we finished B. All right, now I'm going to go from C. So CJ was 8. So CJ is 8. CJ is 8. I'm going to tick off CJ on my graph. And then CE is 7. CE 7, and that's CE also 7, and then we tick it off. All right, the degree of C is 4, and we do have 4 entries under C, and we have 4 entries across from C, so we're done with C. Okay, so it's actually quite easy as long as you just go systematically and you make sure that you're filling everything in. All right, then let's check from E. EF is the only one that we haven't filled in, so EF is 2, and EF over there is 2, and now we're done with that one. Oh, sorry, you can't see that. So EF and EF. All right, E has a degree of 3, and we can see that we, oh, sorry, did we fill in DE? We did. No, we haven't, okay. DE is 8. There we go, DE 8. Okay, so now we fill that one in. So now we check that E has a degree of 3, and there are 3 entries there and 3 entries there. So we're done with E. Okay, and that's how you would go along. So I'm just going to fill the other ones in quite quickly. So FJ we're still needing. So FJ is 4 and 4. So FJ I've done now. FG is 5. FG 5. FG is 5. Oh. GH is 8. GH is 8. JG 6. JG is 6. And it looks like the last one, JH, is also 6. JH is also 6. Guys, what you should notice is that there will never be numbers in this leading diagonal, all right? Because vertex A can't be connected to vertex A, all right? And vertex B can't be connected to vertex B. C can't be connected to C, and so on, all right? So if you have something in your leading diagonal, you must have like matched them up incorrectly, okay? So that must always be blank. So you can, if you want, you can just draw like a dash through it. But you can also just leave it blank, all right? You don't have to do dashes there. I'm not sure. We can check now, actually. I'm not that familiar with it. Yeah. I'll check for you now. We can go look at a past paper quickly. All right, then what else did I want to say? Oh, guys, the top half has to be identical to the bottom half. All right, so if you look at there, we have 8 and 8, 10, 10, 6, 6, 4, 4, right? You can read them off like that. They're basically, it's almost like a reflection in the, across the leading diagonal, if you want to look at it that way. Now, if we count the number of edges in our graph, can we do that quickly? How many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, is it? Sure, I always get so confused when I'm counting them. Okay, did you guys check? Is it 13? Now, guys, we're supposed to have 13 entries in the top and the bottom half separately, all right? Because each entry represents an edge. Yes. Is it 14? Okay, so I miscounted one of them. Oh, I think I didn't count AC. That's the one I missed. All right, 14, thank you. So you can just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so the number of entries in either the top or the bottom half is supposed to be the number of edges. All right. Now, guys, sometimes they say you only have to fill in the upper triangular matrix. If we look at this top half, it does have the shape of a triangle, all right? So then they will only want you to fill that one in, or the lower triangular matrix is only that half. So basically the upper one is the one above the leading diagonal. The lower one is the one below the leading diagonal. They sometimes just do that to save time because it is the same thing that you're filling in twice. All right, so if they're asking that, I think they usually blank out the half that you're not supposed to be filling in. All right, and just so they make it like gray, and then just the open ones you would fill in. But is that fine, guys? How do you feel about that? Okay, cool. Now the next one is the other way around, drawing a graph from an adjacency matrix. So can you guys just copy that matrix down quickly? I'm just going to take away my ticks because I was just doing this myself over the weekend. And I was ticking off the ones that I filled in. And then I'm quickly going to take a look at a past paper and I'll see how many marks these questions normally are. Unfortunately, it doesn't stop here. We actually have to do things using the adjacency matrix that we would normally do using a graph. So you'll see in the exercise, you have to do things like find the upper bound, find the lower bound, and then you need to be able to remember the steps on a graph and then apply them to the adjacency matrix. So it does get a bit more difficult, but I'll just quickly take a look.